Alright, so we are going to learn how to solve a quadratic using the quadratic formula. And we already know our awesome Soldier Boy song to help us remember it. But why am I making you learn a new formula, right? You know how to do lots of other things. So, when can you use the quadratic formula? So let's look at problems that we've had before. So anytime we've had three terms, we've always done the t-chart, right? So on this one, I can multiply my a and my c and get a -8, and then my b would go here. I list out the factors of a -8, 4 times 2. One of them needs to be negative, and it would be that one, right? Yes, because that would give you +2, so that worked out. And then you would put them in these parentheses, and then you would solve them. You set them equal to 0. You would change your signs and get this. But we need a quadratic formula when we can't do that. So let's look at this right problem. Let's say I would still multiply my a times c, and I would get a 15. And then my -10 would go right here. And you'd have to list the multiples of 15, which the only one would be a 5 times a 3. But no way possible can I get that to be a -10. So you can't factor in that case. So you need a formula to solve that quadratic, and so it's called the quadratic formula. So often the simplest way to solve this for the value of x is to factor it, but you just saw that not all times you can factor it. So when it's too messy, or when it doesn't factor, or you just don't feel like it, like who hates that, right? You can always, always, always use the quadratic formula. This formula right here will solve any quadratic you give it, no matter what. So let's have some practice with it. We're going to skip that and that. Okay, so here are your notes. And from our lovely wrap video, we remember the quadratic formula is -b plus or minus square root b squared minus 4ac divided by 2a. So here's what an example looks like. I could factor it maybe, but I want to practice using the quadratic formula. So the first thing you do is find a, b, and c. Okay, and you know from finding the discriminant that a is with the x squared. So my a in this case would be a 1. My b would be a -2. And my c would be a -8. So remember, your a is right here and with that x squared. Your b is this middle term with an x. And your c is this last number with no variable. So now that you have a, b, and c, you just plug it into this formula right here. So the first thing we're going to do, I've got a little bit of a problem that we can just plug in. So I'm going to start -b. So I know b is -2, so I'm going to put it right here. So -2 plus or minus, I now have b squared, so b squared is going to go in there. Minus 4 times a, my a was a 1, and my c was a -8, and then a on the bottom was a 1. So if you'll notice, these are the types of problems that you already know how to simplify. Okay, we already watched a video on it, we've already practiced on it. But the first step is you just need to type in the numbers under the radical. So let me get out my calculator, and I would type parentheses -2 squared minus 4, and you should be doing this with me to get practice, times -8. And I get 36. So 36 is what goes under my radical. So I can start right here, and I've got 2 negatives which make a positive. So let me go ahead and simplify that first. Plus or minus, I know what's under the square root is a 36. And then on bottom, I've got divided by 2 times 1, which is just a 2. The good thing about 36 is it's a perfect square. So I can go ahead and simplify that to a 6. So I'm going to rewrite this over here. 2 plus or minus 6 over 2. So now I'm going to do the problem one way with the plus sign and one way with the minus sign. So I'm going to do 2 plus 6 over 2. And make sure you don't all type it in the calculator at once because you can... Alright, I don't know what happened. Where were we? Okay. Type in the calculator. That was weird. Okay. So I'm going to type in under the radical. So I'm going to type 11 squared minus 4 times 2 times 5. And get 81. So 81 is going to be under my radical. So I'm going to bring everything else down. All over 2 times 2 is 4. So now I need to simplify this 81, and I'm happy it's 81 because it's a perfect square. So let me square root 81 will be 9. So it becomes negative 11 plus or minus 9 over 4. So I need to do it one way with the plus and one way with the minus. So I would have negative 11 plus 9 over 4 as one problem. And then I would have negative 11 minus 9 over 4 as the other problem. So negative 11 plus 9 is negative 2 over 4, which is going to give me negative 0.5. Then I'm going to do it one way with the minus and get negative 11 minus 9 is negative 20 over 4, which is negative 5. So my two answers are negative 0.5 and negative 5. So once again, I found my roots, I found my solutions. Alright, on number 3, we have to get everything to the same side. So just like the discriminant, I'm going to move everything to the left, and I'm going to change the signs when I do it. So when I leave this 3x squared here, when I bring that 5x to the left side, it's going to become a minus 5x. When I bring that 100 to the left side, it's going to be a minus 100. So now my right side equals 0, and I can use the quadratic formula to find the solutions, okay? Alright, I don't know where we left off because I found out there's a pause button, but I am going to find my A, B, and my C now. A is 3, B is negative 5. That's not a 5. And then C is a negative 100. Okay, so now this is confusing when you plug in a negative B, because we're starting off with x equals negative b. Now when your b is a negative already, you're going to end up having x equals negative 5. Okay, so that is okay to have two negatives out in front. So I'm going to have x equals negative 5 plus or minus, wow, why did it change green? Square root b squared, so negative 5 squared, minus 4 times 3 times negative 100. Okay, all over 2 times a, so 2 times 3. So I'm just going to simplify what's in the radical right now by typing in parentheses negative 5, parentheses squared, minus 4 parentheses 3 times negative 100. I get 1225. Let's see if we can take the square root of that. Awesome! So I know the square root of this whole thing is 35. So if I bring this back over here, I found out that all of that was 35 by typing it in the calculator. So now I'm going to bring down, I know that negative 5 is the same as a 5, and then I have a plus or a minus. Okay, and that is all over 2 times 3, which is 6. So now I need to do it one way with the plus and one way with the minus. So I'm going to do 5 plus 35 and get 40. 40 over 6, which is 6.6. So that's one answer. Then I'm going to do it one way with the minus. So 5 minus 35, which is negative 30, and divide that by 6, and you will get negative 5. So once again, my final answer would be negative 5 and 6.67. Okay. If you will turn on the back now. Only 3 more problems and then we're done. So I'm going to start off with number 4. My first step is to get this negative 8 to the left side. So I'm going to move it over there. And when you move it over there, the sign is going to change. So you'll have 3x squared minus 12x, and that is now a plus 8. So all my terms are on the left. I have 3 terms. I can find my a, b, and my c. So my a is my 3, a b is a negative 12, and my c is an 8. So now I'm going to plug those into the quadratic formula. So x equals negative b, so negative 12 plus or minus square root b squared minus 4 times a times c all over 2a, so 2 times 3. So now I just need to simplify this top under the radical with my trusty calculator. So parentheses negative 12 squared minus 4 times 3 times 8. And you get 48. And I know that's not a perfect square, so I'm going to leave it under the radical. I'm going to simplify this minus 12 because I know 2 negatives is a positive. Bring over the plus and minus, and it's all over a 6. Now, we're almost done, but I have to break down this 48. So I'm going to do that a little bit to the side, which is probably going to run into your bottom problem. Or to the top. So 48, I know, is 6 times 8, 3 times 2, 4 times 2, 2 times 2, bring down that 2, bring down that 2, bring down that 3. This is what's underneath my radical. I'm going to try and find pairs of things. I have a pair of 2, take it out, write it once. Pair of 2, take it out, write it once. And I'm left with a root 3. So that is the same as 4 root 3. So that is just going to replace the square root of 48. Okay? So I'm going to have 12 plus or minus 4 root 3 all over 6. Now, I need to reduce these coefficients, fractions, by seeing what number goes into all of them. 2, I know, goes into all of them. So I'm going to divide each of those numbers by a 2, but I'm not going to touch this radical sign. So 12 divided by 2 is 6, plus or minus. 4 divided by 2 is 2, all over 3. Now, I know this is reduced because 2/3, I can't reduce it anymore. I could reduce 6 divided by 3, but since this 2 is right here, I cannot reduce it. So that's my answer. All right. Let's move on to number 5. So make sure you have this because I'm about to erase this whole mess right here. If not, pause. Okay. So my right side is not equal 0. I have to get rid of that 10 by minusing 10. Alright, part 2 of quadratic formula. We're starting on number 5. I need to move this 10 to the left by subtracting it. I know 27 minus 10 is 17. That right side is 0, which is good. I will bring down x squared plus 10x, and that was a positive 17. So I have 3 terms. I can find an a, b, and a c. So my a is a 1, my b is a 10, and my c is 17. So now I'm going to plug it into the quadratic formula. So I'm going to start with x equals negative b. So I'd have negative 10 plus or minus square root b squared, so 10 squared, minus 4 times a times c, all over 2a. My a is a 1. Okay. Once you have it plugged in, you can type this loveliness under the quadratic. Let me pull out my calculator. Okay. I started typing it and then I got stuck. So when you type in this top part under the radical, you will get 32. And I know 32 is not a perfect square, so I'm going to leave it under the radical. So, I will have square root, what was it? Gosh, so late. 32. Plus or minus the negative 10 over 2 times 1 is 2. So now I need to break down 32 over here. And I know it's divisible by 2, so let me check 32 divided by 2 and get 16. I know 16 is 4 times 2. I can stop right there because I have a pair of 4s. Take them out right at once. So 4 root 2 is the same thing as square root of 32. So I would have 4 root 2 right here, just replacing it, plus or minus negative 10 over 2. I need to simplify these numbers and see if any number will go into all of them, and I know they're all divisible by a 2. So divide everything by a 2, but remember, don't touch this inside radical. I would get negative 5 plus or minus 2 root 2. And I could put it all over 1, since 2 divided by 2 is 1, but I can just stop right there. And I'm done. Time for the last problem. So I'm going to erase this to get some more room, so please make sure you have this written down. Alright. First thing, move this 11x over there, and it will become a negative 11x. I'm going to go ahead and write it in order and make sure that negative 11 is going to go in the middle and that plus 5 goes on the right side. So now I can find my a, b, and c. A is 7, b is negative 11, and c is 5. I'm going to plug it into my formula. X equals negative b, so negative 11, which is okay, plus or minus square root b squared, so negative 11 squared, minus 4 times 7 times 5, 4ac, all over 2 times 7. Oh my gosh. Last problem. Plug in the top part under the radical into your calculator, and you would get negative 11 in parentheses squared minus 4 times 7 times 5. Uh-oh, you got a negative number under a radical. Can that happen? No. So, because you got negative 19 under that radical, you can go ahead and stop right there and not do any more work because you know there are no solutions. There are no real solutions. Okay? So once again, anytime you type in all this mumbo jumbo and you get a negative number under the radical, you can stop there because you cannot go any further. You've got no real solutions. So these are all examples of how to solve the quadratic formula. I know it's long, I know it's tough, I know it takes 10 minutes to do a problem, but you can do it, and it solves them every single time.